welcome to the April Ask Tom Database Security Office Hours. My name is Richard Evans, and I'm joined by Peter Wahl here. And we're going to do a presentation. Peter's going to do a presentation on Oracle Key Vault and its capabilities. Okay. Now, just a reminder, this call is being recorded, and it will be available on the asktom.oracle.com website in the next few days. We've got 38 to 40 presentations out there now. So over 3 years worth of presentations that Russ and Peter and Alan and Michael and the team have done on database security products. So if you have any questions about products, please check the asktom.oracle.com database security page. And we've probably done a video on it, okay? So if you haven't been here before, thanks for joining us. This is a kind of a direct line into database security, development, product management, where we try to help you guys understand what we're working on, what we've released, what's upcoming, and then give you an opportunity to ask questions of us too, okay? So you're welcome to put your questions in the Q&A at any point in time, and we'll go over those at the end of the session. If you have any questions that you'd like to ask, but you don't want to ask in the chat, I'll put my email here in the chat and you can email me directly. And if they're for Peter, I can pass them on to Peter. If they're about any Oracle database security products, they're fair game. Feel free to go ahead and email us. If you have a question about support, please file a service request on that. Like that goes through support. And if there's any help that we can offer there, then we work with the support team to do so. Okay. All right, let's go ahead and move to the next slide here. And let's do some announcements. All right, coming up here soon, you're going to see the April quarterly patch set get released here. So please try to stay on top of these. These are critical patch updates that are bug fixes and security fixes. So there's a My Oracle support note out there, 2118.136.2, that you can look at for those patch numbers. You can also go to oracle.com/security-alerts to see what's out there on all of the various Oracle products. So, but please try to stay up to date on those. You know, there are some good fixes in that January patch set as well. So Peter Wahl and his team with TDE are always constantly improving the product. And so that 19.14 January patch set has some good features and bug fixes and security updates in there. Okay. Now there's an end of life announcement here, right? So end of support for Oracle Key Vault 18. So Oracle Key Vault 18.8 was that terminal release. We want everybody moving to 21. Peter's going to talk about those latest updates in 21 today, but that support ends this month, okay? So we want you guys moving toward or being on 21 for Key Vault at this point, okay? Lots of really cool features in 21 that you're going to want to take advantage of. Another update here is Audit Vault and Database Firewalls released 20.7. And this has got a lot of neat things here. This is just kind of highlight. And I believe next month, Nazi is going to talk about the new things with ADVF 20.7. But some of the highlights, being able to decrypt TLS traffic going to Oracle databases, some database firewall policies, being able to export those policies, you know, from one target and bring them onto another. There's a shadow Audit Vault server there too that monitors that Audit Vault activity and stuff that's embedded there at no additional costs, and just some additional reporting capabilities there too. So the Audit Vault and Database Firewall team are hard at work on that product all the time. So if you haven't, please go ahead and patch to 20.7, right? Because that patch includes not just these additional features, but those security patches that you're looking for, those bug fixes that you're looking for. So please make sure you try to stay up to date on ADVF as well. Okay. Now, a couple of support notes here. Peter and his team have done a fantastic job at trying to get everything they're working on in all these various scenarios into the Key Vault and the advanced security documentation. So transparent data encryption and redaction are part of that advanced security option. And so go take a look at that documentation. All right, so without further ado, I'll turn this over to Peter. We'll go ahead and turn off my camera here so you guys are are talking to Peter instead. So awesome, Peter.
Okay, welcome everyone. This is a presentation about Oracle Key Vault 21.4 that we released maybe 2-3 weeks ago, and it has exciting new features. It's really, if you ask me, I would have named it OKV 22 because it is almost like a new release. Okay, so I would like to give you a quick overview on where TDE and Key Vault fits in. So here you see the maximum security architecture. Okay, and underneath the database, you see the encrypted, the not yet encrypted tablespace, and it will be encrypted in the next moment. There we go. And then, of course, we need to keep the encryption keys safe. That is what Key Vault is used for. All right, a quick intro into Transparent Data Encryption. It's a very old and a very mature product. It was invented in 10GR2 with TDE column encryption, and in 11GR1 we added tablespace encryption to it. And that's basically the only option that we are focusing on today. TDE column encryption has a couple corner use cases, but usually we recommend our customers to use tablespace encryption and just encrypt everything. We support all the important encryption algorithms. If you could quickly go back, please. It doesn't require application changes, right? Because we encrypt on a layer where we don't know what the database object is. TDE encrypts the data blocks of the table spaces. And so at that point, it's only ones and zeros for us. We don't know if this is an index, a table, or whatever you put into this database. We don't know what it is, and hence we don't require application changes. The performance overhead is very low because we automatically outsource crypto operations to the CPUs if it's available there. So we have the Intel CPUs with AES-NI. Many years ago, that was added into the Intel CPUs. And also the Spark chips also have a crypto acceleration built in. As opposed to the early days when TDE was available in 11GR1, 11GR2, getting to encrypted tablespaces wasn't trivial. You needed to do this by copying your database objects from a clear text tablespace into an encrypted tablespace. But now, thanks to cloud, where everything is encrypted, we had a few ideas that we backported all the way to 11GR2. Key management, which is of course very important, is done with a TDE wallet, which is an encrypted container outside of your database, but on the same server, or Oracle Key Vault, which is the other topic of this presentation. TDE tablespace encryption works with everything that the database can do. So with DataGuard and RAG and Golden Gate and PDBs, with RMAN and Datapump and Exadata. So whatever deployment option you use for the Oracle database, TDE can be with you. We continuously improve TDE and its usability. So as I said earlier, we backported the capability to offline encrypt existing tablespaces and encrypt new tablespaces by default, all the way to 11GR2 and 12.1. Right? That means that if you have an application that you install into one of those older database releases, and of course those installation scripts don't have the encryption syntax, we would encrypt the tablespace regardless. As soon as your PeopleSoft application that you installed into your database, it creates 100 tablespaces, all of them would be encrypted immediately. With 12.2, we allow you to online encrypt a tablespace, which also implies that you can online rekey a tablespace, so you can change the data encryption key. We introduced ARIA and seed encryption algorithm, and we finally are able to hide the key store password from the DBAs. So on your Secret Plus command line, we no longer need the key store password. That is replaced by a fixed string that supports your separation of duties and also allows for automation if you have a process that needs to open or close the key store, you don't need to guess what the password is. It's just replaced by always the same string. Oracle Database 18 introduced the per-PDB key store in a very limited availability. It was only available on engineered systems on-prem, but due to a software bug, the database complained that it's not available on engineered systems on-prem, and in the Oracle Cloud, the cloud tooling didn't support it. So that's a feature that nobody really used, or only very, very limited deployments had a per-PDB key store. But the most important thing, what I think, is that we finally replaced the dependency on secretnet.aura by introducing two system parameters, wallet root and TDE configuration. Because the environment variables that you need to configure TDE in secretnet.aura, sometimes they are not set to the correct values, and we had some big problems that came out of this. Now that we have internalized those values and they are maintained per database in the database, this is much more stable. RMAN allows you to restore or duplicate as encrypted or as decrypted, which was invented or which was added into RMAN to support a journey from your on-premise into the cloud or backwards. So if you move your database into the cloud, you would restore or duplicate as encrypted. If you don't have a TDE license on-prem, you can still encrypt in OCI, and this would happen basically in one go. If you would like to get this database back on-prem, you could say restore or duplicate as decrypted, and you would get a database back on-prem that is not encrypted and doesn't need a TDE license. In 19C, we introduced an additional key in the database that allows us to finally securely encrypt system sysaux temp and undo. If you close your key store, this key is not affected by this closed key store, so your database continues to work. My personal recommendation is to not encrypt temp and undo. That doesn't really make sense, because from day one, from Oracle 10G R2, we tracked encrypted data. And as soon as we write data that came out of an encrypted column or out of an encrypted table space, as soon as we write anything of those sources into temp and undo, it would be encrypted anyways. So encrypting temp and undo table spaces is not really necessary. Maybe it introduces a performance differentiator, so I would be careful doing this. And finally, the per-PDB key store has been released for everyone, everywhere with the Enterprise Edition, except in other clouds. So you can use per-PDB key store on legacy hardware, on-prem, wherever you like. In 1911, 12, and 13, you need a patch, and in 1914, it's finally baked into the release upgrade. You don't need a patch anymore. Okay, so why do we need TDE? I mean, it's clear, right? There are public and private security laws. You may have internal security policies. And also, if you have breach notification laws, they may have a get out of jail card when encrypted data has been breached. And we try to make it even easier for you to get your database encrypted. As I mentioned earlier, in 11.2 and 12.1, we have offline encryption and encrypt new table spaces. Of course, all those changes, those additional features are cumulative, so that they're carried over into the newer releases. In 12.1, 12.2, 18C, 19C, we can online and offline encrypt. In 21C, DBCA can create an encrypted database. So the 21C database can be born encrypted. You never will have this database not encrypted. So now let's talk about Key Vault. Key Vault is really necessary because we need a key management solution that scales to the load that our customers are putting on this key management system. If you go back 10, 15 years, when at the time before we had Oracle Key Vault, we partnered with HSM providers and helped them integrate the Oracle database with HSMs, because our customers only had 1 or 2 databases encrypted. Of course, that's no problem. to put those keys into an HSM. Now, suddenly, some of my customers in the financial industry tell me that they have to encrypt every database. Even if it's only test and development, it has to be encrypted. Existing databases have to be encrypted by a certain date. So that puts us into somewhere between 8,000 and 12,000 databases, and all of them need a master key. Nobody is going to manage 8,000 or 12,000 wallets, right? We need to do something here. And for this, we introduced Oracle Key Vault. Oracle Key Vault is a soft appliance that has the flexibility to can be installed on dedicated servers as a VM guest or in your OCI tenancy from the cloud marketplace. You can cluster up to 16 OKV nodes together. And this helps us to provide scalability horizontally by adding more nodes, or vertically by putting OKV on bigger servers. And why Oracle Key Vault? So first, it provides the scalability that you need to support key management for hundreds or thousands of databases. Right? Our own global business unit, the support group that runs the databases for those applications in the Oracle Cloud, meanwhile, they have 22,000 pluggable databases key managed in multiple 8-node OKV clusters in OCI. So that's one of the largest deployments, and it just works, right? We support, or OKV has been purpose-built to support all possible esoteric use cases that the Oracle database allows you to do. So if you have active data guard or normal data guard, including parsing, Oracle RAC, Golden Gate, local remote clones, PDB relocate, PDB carousels, sharded databases, and of course, as I mentioned earlier, the per-PDB keystores, or isolated PDBs, as we call it. Everything is tested, supported, under load. So we not only do functional testing, we also do performance testing for our databases in our testing teams. And they encrypt everything, they put the keys in OKV and see how OKV works. And it's working. Again, we cannot support third-party HSMs, because if we were to support them, we would need to repeat the entire testing scenario again with different makes and models of hardware security modules, and we cannot do this. So we cannot help you. Third-party HSMs usually don't scale to the really big load that the Oracle database puts towards their key management system. HSMs would certainly work with the functional testing. I can onboard any database into an HSM, but then afterwards, if I have an Exadata system with 500 pluggable databases and all of them are turned on at the same time, I'm not sure if all PDBs come up. So, as I mentioned earlier, OKV has been purpose-built to support the Oracle database and all possible deployment scenarios. But we like to break out of this limitation. So what we have done is we provide key management to many more items. So as you can see here on the left side, of course, yes, we do key management for TDE-enabled databases. You can also upload and download any wallet into OKV and keep it safe, and maybe even retrieve it on demand. We do secrets management. You can put your database account passwords for your maintenance scripts, your SSH private key. If you have implemented public key authentication, you could move the private keys off your servers into OKV, and the operating system users who need to log into a remote machine would get this private key out of OKV only for the short time when they really need it. The integration with the ZF as a storage appliance, there are 2 points of integration. One is that OKV can provide key management if the ZFS is encrypted. And the other one is that ZFS is one of our most favorite backup targets for the OKV backups, because you can define immutable snapshots. And we really like this feature, because it plays nicely together with a scheduled backup deletion that we introduced in OKV 21.4, but I will come to this later. We integrate with the Zero Data Loss Recovery appliance. We provide key management to Golden Gate encrypted trail files. We provide key management for MySQL and MongoDB. We provide key management for your databases on XRCC. We are built into the provisioning flow of the autonomous database on XRCC. And the C and Java SDK that comes with OKV 21 allows you to basically convert any application that you have that somehow deals with encryption keys or secrets to leverage Key Vault as a secrets or key management repository, and your applications can retrieve those secrets and encryption keys and whatever other things are sensitive on demand out of OKV. So this is a short build. As I said, we can deploy OKV as a cluster. Each cluster consists of up to 8 read-write pairs. And here we have one read-write pair that is stretched across data center node, that is across data centers. So if your primary databases are in data center 1, your standby database is in data center 2, then we want OKV deployed in parallel to your data guard setup. Now, if you a 2-node OKV cluster gives you continuous read availability, because we can only remain read-write for the time that we have both nodes available. So if you do a set key operation on your primary, the primary database will most likely talk to the OKV in data center 1, tell the OKV, hey, I need a new key. OKV will create one, replicate it to the other node, and then give the prompt back to the primary database. And then the rekey operation will be signaled to the standby database, and the standby database gets its key from the other OKV. There's no downtime for your standby database. There is no MRP that stops because the encryption keys are available immediately. So that is why you want to do this. If you take one OKV down, let's say you upgrade, the other one becomes a read-only node because we cannot replicate our content. And only after you restart your OKV node, it joins the cluster again, and then you get your read-write pair back. Next slide, please. If you like to extend your cluster, you add another read-only node, and we add another one and pair this node, and then we have 2 read-write pairs, and all of them are talking to each other. You can define cluster subgroups, which defines for your endpoints which OKVs to contact first. And that is how you would deploy an OKV cluster across your data centers. Any one of those 2 data centers could also be your OCI tenancy. Right? We have OKV available from the Oracle Cloud Marketplace, and you could deploy OKV from the Cloud Marketplace in your tenancy and say then data center number 2 is your OCI tenancy, and that picture would not change except that the OKVs are deployed from an image in the Cloud Marketplace and not manually. So, as I mentioned earlier, the progress that OKV makes is so quick that in the classical world, you would say that, hey, that's almost like a new release every time. With OKV 21.1, a year ago, we introduced secrets management. We completely rewrote the RESTful services. We made it will be, at one point, the RESTful services will be so powerful that you can do everything that you can do in OKV using the RESTful API. So this is growing continuously, and we basically started fresh when 21.1 came out to be able to expand into all the other areas for monitoring, to set up backup destinations and backup schedules. And all these things can be done with RESTful services. We allow the administrative users to be managed in Active Directory. We have, as I mentioned earlier, the C and Java SDK. We have a new backup protocol, SFTP, which, for example, enables us to put the OKV backups into the ZFS storage appliance. Okay, so let's fast forward to OKV 21.4, which we released a couple of weeks ago. And the biggest change here is that you can run OKV 21.4 in what I prefer to call HSM mode. We also allow you to replace the self-signed certificates in OKV with your corporate certificates. And there are a few other changes that I will talk about in a minute. So here is a quick overview on how the HSM mode works, or the extractable keys. This is the default behavior of OKV. OKV is not an HSM, meaning we are not FIPS level 3 certified. We can't, because FIPS levels 2 and 3 need hardware support. We are a soft appliance. We can be installed on any kind server. If you have a FIPS validated hardware, then this would certainly help OKV, but OKV itself is not validated to the higher levels. This has the benefit that the master encryption keys that are stored in OKV are allowed to leave OKV's boundary. So in this case, we keep the master encryption key stored in memory of the database in the PKCS11 library, and we also have an optional persistent cache which sits between the library and OKV in the logical picture, but it would still be on the database machine. So here the keys can leave OKV, and of course that makes for a very fast encryption and decryption solution, right? Because we cache the key in the PKCS11 library by default for 60 minutes, and only after 60 minutes we reach out to OKV and refresh the key if it's needed. Well, now if you look at the non-extractable keys, now we move this encryption and decryption process back into OKV. So the database needs to talk to OKV. If we need to send the data encryption keys over to OKV, get them decrypted, and send the decrypted data encryption keys back to the database, so that the database doesn't need to do anything differently. You see that for the database, nothing has changed. It's only between the library and OKV that we made a change that changes the behavior of OKV and the way that the library interacts with OKV. So this is what we call the HSM mode, or the non-extractable keys. There are a few things to consider. So when would you use the non-extractable keys? I would say only very selectively, because we expect that the load on OKV and on your network will grow exponentially. So as I said, start slowly, right? Don't turn it on for your OKV cluster and have all your databases use non-extractable keys. Be careful, be slow implementing it, because it will increase the load on your network and on OKV, right? Because all the keys will travel over the network back and forth. This will increase network traffic. This will increase the load on your OKV cluster. What we're basically doing here is we're inheriting the limitations of hardware security modules, but on the other hand, we can do this because we scale. You can put OKV on a bigger server if it gets too slow, or add more cluster nodes to it. And of course, if you have non-extractable keys, there is also no persistent cache that can potentially bridge your time when your databases lose connection to the entire OKV cluster. So if your network goes down and your databases cannot see the OKV cluster anymore, there is database downtime because they cannot reach OKV. If you don't use the non-extractable keys, we put the keys into a persistent cache, which has a default expiration time of 24 hours. So OKV can disappear from the network for 24 hours and your databases wouldn't even notice. If you have non-extractable keys, your databases will notice that OKV disappeared from the network. So you want to be careful doing it, but we had customers who asked us for this feature, so we built it. So we also improved our certificate management inside OKV. So one is that you can replace the self-signed certificates inside OKV that we use to protect the connection between OKV nodes and OKV servers and the endpoints, your databases, with a self-signed certificate. You can replace this with a certificate that you have signed with your own corporate certificate authority. Right? If you are a big enterprise, then most likely you have your own certificate authority. You can sign your certificate authority signing request with this from this entity and import it back into OKV, and then OKV has an intermediate certificate authority which allows you this improvement. You can basically freely specify the validity period of certificates. We can now span a much larger time range where those certificates are valid. So we no longer force you to replace all certificates every 1,000 days or 2.5 years. You can now control this yourself. You also may know that in Oracle 18, in OKV 18, we introduced the transparent certificate rotation between OKV and your databases, right? You know that the channel between your database and OKV is protected by TLS 1.2. It's mutually authenticated, so we need certificates. Those certificates always surprisingly expire at the worst possible time. It surprises people like Christmas, right? You know the Christmas date exactly, but still there are people who do panic sales on the day of Christmas. And so it always comes as a surprise. And if we now alert you very, very clearly, we understood that the alerts were missed sometimes. So now we alert really, really intensely if we notice that your expiration date gets closer to the date when it happens. And so if you start early enough, if you don't wait until the last minute, then you can trigger certificate rotations from OKV to all your connected databases. And this will happen without database downtime. It's just a little bit of a slow process because we cannot allow the random pool inside OKV to run out. That is why we need to create certificates slowly. We do this in batches of 5. And then after that, we have to wait a little bit for the random pool to refresh. And so we need time to do this. And we also need to build a new OKV client. We need to ship it out to the endpoint. It needs to be installed automatically. All those things happen automatically if you don't get over that time hump where your certificates are expired. This becomes nasty. If you do it in time, everything is good and there is no database downtime even. Privilege granting restrictions for OKV administrators. In older OKV administrators, if I am the system administrator in OKV, I can grant my system administrator privilege to the key administrator, or the key administrator can grant his or her privilege to me. Right? This is what some customers call a privilege dilution, and they didn't like that. So what we built is that by default, we leave it as it was, but you have the option to go into the recovery pages that you see on top left. And if you look for the system administrator, you could unselect the allow forward grant checkbox. Now, as long as it is checked in the lower right window, you see that I'm logged in as sysadmin, and I grant my privilege to the key administrator. If in the top left window, the allow forward grant would be deselected, then I couldn't do this. And also it allows me to allow key admin to grant system administrators to other users. This checkbox would also not appear if I wouldn't be allowed to forward grant my privilege. So with this, you really get 3 or 4 users in OKV with predefined privileges. You would have one key administrator, one system administrator, an auditor, and an endpoint administrator. and they cannot grant their privileges to somebody else. What does OKV do with XRCC and autonomous database on XRCC? So OKV is the only possible key management solution for autonomous database on XRCC. Because it's autonomous, those databases are managed by Oracle DBAs. They have to manage a lot of databases, and they want all databases to look the same and behave the same. Otherwise, they couldn't be treated as autonomous. So we cannot manage third-party software that upgrades at the different time intervals than the Oracle database, that behaves differently across HSM upgrades. We just cannot do this. We cannot have third-party software in an autonomous database that is completely out of control for anything that Oracle does. And that is why the only supported key management solution is Oracle Key Vault. And the way that this works is that if you go through the provisioning workflow to create a new autonomous database on XRCC, you have the ability to register an existing OKV cluster, an existing on-prem OKV cluster, as a key management resource in your OCI workflow. And this key management resource will be applied, or can be applied, it's not a must, you can then be applied to newly provisioned autonomous databases. And then the onboarding happens automatically because OKV has RESTful services. And that is how we onboard this database. And by the time the database is ready for the customer to use, it's encrypted, the keys are in OKV, everything has been taken care of. For XRCC, this process is manual for now, but also here again, note that we do not support third-party HSMs. That's also valid for XRCC, right? The Oracle database team does not support third-party HSMs, period. It doesn't matter on which platform you install your database, and the higher the concentration of databases is on a server, the higher the load will be on your key management appliance. So you need something that scales and grows with your load, and that's OKV. So there are two more notes that explain how to manually or automated migrate the existing TDE wallet into your on-premise OKV cluster. And of course, the XRCC team is planning to automate the onboarding into OKV to somehow make it similar to the experience that we have for the autonomous database. So this will come in the near future. For now, this is a manual process. Okay, a quick show on how the extractable keys look like. So if you do an OKV util list, we introduced a new switch, -A, and there you see a new column called extractable. So the default behavior is your keys are extractable, so they can be cached in your database. And now I go into OKV, I make my endpoint non-extractable, and I do a set key operation. All keys afterwards are non-extractable, as you can see in the output of OKV util list -A. This key is no longer extractable. And we can prove this very easily, because if you list the persistent cache, you will see that this persistent cache this third key will never be copied into the persistent cache. And also downloading the wallet, you will get an error message that says, hey, this key is not extractable. You cannot download this key. You can download the other two keys, but not the non-extractable ones. So this is one way to very easily demonstrate non-extractable keys. Of course, once you migrate your databases into OKV and they make use of non-extractable keys, you should monitor your network and the OKV load very closely and see how that behaves. Okay, so what is OKV and ransomware? Unfortunately, TDE does not protect you from ransomware attacks, right? If I'm a hacker, I can re-encrypt the encrypted table spaces. There's nobody holding me back. But it's even easier. I can just go ahead and remove or encrypt the wallet. And then if you do not care, if you don't properly protect the wallet, you did the next ransomware attack to yourself, right? Because I can just go ahead and remove and encrypt the wallet, and then I only give it back to you once you pay me. And if you don't take good care of your wallet. So the 1, 2, 3 backup method is something that is implemented by TDE and by OKV together. If you make any changes to the TDE wallet, we automatically enforce you that you use the with backup clause. That creates a backup. This is backup number 1. It should be a backup that is immediately available on the same file system, maybe. And so if you mistype a new wallet password, if something goes wrong while you rekey, you automatically have a backup that was created before we committed the change to the wallet. That's number 1. Number 2 is something that is away from my file system, but immediately available. That would be an upload of a wallet into OKV and a download of my wallet from OKV. This is available immediately. Backup number 3 is remote and only available after a delay. That goes into the OKV backup. Right? It takes time for me to restore that OKV backup into a new OKV and get my encryption key, my password, whatever is sensitive back, but it's also safer than everything else. This is the 1, 2, 3 method. The first one, the first backup is available immediately. The next one remote, but immediately. And the third one is some offline storage where it takes time to get it back. So with OKV, you could either upload the wallet into OKV. This is number 2 because you can also download. And the wallet becomes part of the regularly scheduled backup. This is number 3 of the 1, 2, 3 backup. Your encryption keys are part of the larger backup that contains everything that belongs to OKV. And you can also migrate your database to use OKV exclusively. Whatever method you prefer, most customers use the online master key. Your keys are off your server. So that is one thing that makes it less easy for ransomware attackers to get to your database, right? If you remove the keys from your encrypted database. So that's just my thought in terms of ransomware. Next one, please. Oh yeah, learn more. Here are a few resources. The Oracle keyword documentation, of course, which I always encourage you to read. We have the Oracle Keyword Live Lab, where you can experience for yourself all the many use cases that OKV can address. It is currently using OKV 21.3. The upgrade cycle for Live Lab is a little different. The next one is the link for the OCI image on the cloud marketplace. We have a homepage on OTN on oracle.com. And of course, if you would like to watch any of the videos that I created, then you can certainly search for keyword in the product management YouTube channel. That's it. Over to Rich. Thank you.
Thanks, Peter. That was great. So I shared all of those links that Peter had in the chat. So you can pick up those links to the documentation, the live labs, the Oracle Cloud Marketplace image as well. And so take a look at those when you have time. Next month, I think we're going to talk about those updates to ADVF. So Auto Vault and Database Firewall 20.7. There's some exciting features that we talked about in the announcements. We're going to get Nazia on here and have her run through those.